Okay, so thank you for watching me again and listening to my beautiful voice. I know it probably puts you to sleep. It soothes you, though, maybe is a stress reliever, I hope. And I know that you're probably watching these videos on a Friday or Saturday night instead of going to a basketball or a football game or instead of going to the movies, because I know this is more important to you, the wonders of HPLC software versus cheap entertainment value. Okay, so we are going to pick up from where we left off previously, and this is the Detector tab, which is right up here at the very top. And the detector that we have on our HPLC, this one at least, is a UVVIS detector. So the UVVIS detector is the eyeballs of the instrument, and we have to make some settings here. We have to let the instrument know what to see and what not to see. So we have to tell it to kind of fine-tooth and become very specific on what I'm looking for. And the way that I do that is I go into the Detector tab and I make these types of settings. There's only one thing that you have to change here. That is it. And that one setting is the wavelength setting. All the other ones are default. So if we look at under the model, lamp, polarity, and response, these are default settings that you do not need to worry about. This tells me a little bit about the detector and how I want it to operate. And the polarity, response, and the lamp is something that, well, I don't need to be making changes if I don't need to be making changes. I'll leave them be. In the box below, I see a thing that says wavelength. And right now it says wavelength channel 1, and that box is a white box, which means that I can type something in here. Right now it's set at 273 nanometers. Every compound that you run on a UVVIS detector has something that we call a nanometer or Lambda Max. Okay, so a Lambda Max represents the wavelength that a compound will absorb light, specifically UV light. And it is the number where it reaches the maximum absorbance. Okay, so in other words, let's say that I am analyzing a sample of caffeine. Caffeine absorbs UV radiation. 2 to 400, it absorbs it. But there's a particular number, one number, that caffeine behaves very well with, and that's 273, which is why this number is in the software system right now. Now, at 200, caffeine will absorb, and I can get an absorbance from it, not a problem. At 220, caffeine absorbs. 225, caffeine will absorb. 240, caffeine absorbs. 250, caffeine absorbs. 260, caffeine will absorb there too. 265, guess what? Caffeine absorbs there. But at 273 in particular, caffeine absorbs extremely well. And that is what we call Lambda Max. 283 doesn't absorb as much. 290 doesn't absorb as much. 300 doesn't absorb as much. 325, the absorbance goes down even more. So Lambda Max is the wavelength that caffeine absorbs the best. And that is why I dial this machine into 273, because I want this to be as sensitive as possible. So again, I need to know what I'm looking for. I need to know what I'm analyzing. The machine's not going to tell me this information. I have to look that up. And again, if I'm given a laboratory practical or a lab experiment, it's probably going to tell me the lambda to go into. And it says, make sure that you are analyzing this component using this value. And it will say 273 nanometer or 260 nanometer. Okay, well, if I need to change it, what I do is I just highlight it and I go maybe to 254. And I just key it in. And it's okay. That's all that I need to do for now. You just key it in. So maybe I'm looking for something like benzoic acid instead of caffeine. Well, I take a look at benzoic acid, I look it up on the internet, I look it up in a reference book, and it's going to say benzoic acid's Lambda Max, or its molar absorptivity is based at 254 nanometer. That is a number that will be given. And again, if you're watching because of the Chemtechathon competition, this number will be provided to you in form of a reference book. You will have to look this up in the Merck or the CRC, and it will tell you what you should be dialing into. We are not going to provide that information to you at all. So, hint, 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 be sure that you know where to find that info. Alright, so that's all that I need to do on the detector tab itself. The output that's down here below, don't need to do anything there. By settings, that's default. Controller. If I click the controller tab, I do not have to do anything here at all. This is by default setting. The machine understands what to do with the controller. I don't need to tell the controller how to control itself. So this is if I'm using a different model or a different type of controller. So bypass that tab. Nothing that you need to make there. Autosampler. This is that magic box that I've paid so many thousands of dollars for. And this magic box allows me to inject multiple samples at one time. So if I look at the Autosampler, I've checked it to let the machine know that I want to use it. The sample rack, it says, okay, well, right now what's in here is a 1.5 milliliter sample rack, and it can hold 70 vials at one time. If I click the drop down box, I'm going to see a whole different slew of different options for me down through here. So one of these is a 1 milliliter cool, 4 milliliter cool, a 1.5 milliliter with 105 vials. What we use most of the time here is this 1.5 mil sample vial, which you saw in a picture in a previous video, and the 70 vial tray. So each tray will hold 70 of those little containers. So that means I can load up 140 samples and have it run, because the Autosampler can hold 2 racks, not just one. But that's by default where it goes. Make sure that that's the setting that's there. 1.5 mil, 70 vials. The rinsing volume. Well, there's a needle that will go down into that vial and suck sample out. And that needle needs to be cleaned, because I'm going to be injecting multiple samples with that same needle from different sources. So I just want to make sure there's no carryover or contamination. So the rinsing volume is 450 microliters. So it's going to suck up 450 microliters of rinse. It's going to rinse the needle out, and out it goes. It gets disposed of. The needle stroke is something that you don't need to worry with. It's basically how far we want the needle to go down into the sample vial. The rinsing speed, well, do we want it to soak out into a hot bath, or do we just want it to kind of do a quick dip and then clean it off? So that's the rinsing speed. The sampling speed is the same way. Do you just want it to puncture the vial and quickly shoot up a sample, or do you want it to puncture the vial and slowly suck the sample up? These are default settings. Do not change them. The purge time. Yes, the purge. Go home, lock your doors. Barricade your windows. They're coming. Okay, the purge time is how long we want the Autosampler to purge itself. So a deep clean, that's what you need to think of it as. So we like to do a deep clean before and after a analysis has been done. So you do not have to do a purge method. This will be done beforehand. You do not need to worry about it at all. Okay? So leave that as is at default. Rinse mode. Well, how do you want the needle to be rinsed? So if you click the drop down box, well, you can elect not to rinse it at all. I don't know why you would want to do that. You could do before you suck a sample up, You could do after you suck a sample up, or you could do before and after you suck up a sample. My advice is to do before and after. That's default where it typically goes, and that's what we like to do because we like to be super clean. Some of these things we detect at a very low level, and any contamination at all causes us problems. So before and after aspiration. And the dip time. When the needle goes down into the rinse, how long do you want it to stay there? For 2 seconds, for 10 seconds, for 15 seconds? How long? 2 seconds is default. That's good enough for what we do for the most part, and that's where we'll keep that as well. So the Autosampler, you do not make any changes on. This is just me walking you through the different tabs so you feel comfortable overall with the software. And then the auto purge button, you do not have to do an auto purge again. This is something that we do for you. And if you're even in the program and you're working with the HPLC instrument, this purge has probably already been done as well. We'll show you how to do it once, but after that, we typically do it because, again, it takes 30 minutes of laboratory time, and we want this machine ready to go by the time you come in. So if you look at all of these tabs, acquisition, LC program, pump, detector, controller, autosampler, and auto purge. After you make the settings of what you need to do, you then need to come over here to the right and you need to click the word download. When you click download, it's going to say current method file will be saved, and this box will show up. Okay, well, my advice here is do not save it as caffeine. That's how it's going to title it now. So what I want to do is I want to create my own file name. So I'll go up here to File, and I will go to Save the Method File As, right? I just made all of these settings, and I want to make sure that I don't have to go through all of these settings again. So by default, it's going to go into this folder called caffeine right now. If I click the drop down box, I'm going to see some tabs that are listed here. One of these is called LCSolutions. That's where a lot of this will be located. And then here we're going to put a folder. And what I'm going to do, I'm going to call it Chemtechathon. So if you've got a method that you want to do for the competition, if you're involved in the competition, then you go into this folder of Chemtechathon, and now I'm going to name it something. So here I'm just going to put my initials, and I'm going to put test method. Whatever you want to name it as, you name it that way, and I'm going to hit save. Okay, so when I do that, up here at the very top, you're going to see data acquisition TH test method. It is now saved in the software system. If you hit download from this point, then it's going to go through and it's going to save those changes that you made as TH test method. It just didn't want you to overwrite the method that was currently up. Alright, now if I need to make any change at all, let's say I need to make a pump change. So here I'm going to do maybe 0.9 instead of 0.750. Well, I'll change it there, and I hit download. It says, do you want to save these changes under that name? Yes, I do. Thank you for reminding me. And I hit OK. So that one's saved. Well, let's say I go back and I figured I put the wrong detector wavelength in, and now I'm going to change it to maybe 273, which is what it was before. Okay, well, when I do that, if I hit download, it says, do you want to save this change that you just made? Yes, I do. Thank you very much. So I hit OK, and then that sends the signal over to the machine when you get ready to start an analysis run. You won't see any settings on the machine change right now. Only when you inject your very first sample will it start making those changes. And you're not injecting a sample yet. The only thing that we've done is made the method changes or the settings for the method. That's all that we've done. So when I go through and actually hit start, that's when it will relay that message over to my instrument for me. Okay? So that's where this video is going to stop. In the next one, we'll talk a little bit more detail about this whole system and about how to operate it the best way possible.